Welcome back to Mechanical Systems Design. In this video, we'll talk about the course structure and why the course is designed this way. Before you watch this video, it's best to read the syllabus in detail. It'll make a lot more sense. First, let's put this course in context.
This class builds on the prerequisites of physics, statics, strength of materials, and the design and manufacturing sequence, the core for the BSME program and the product design program. And it builds towards the capstone design courses. So what do we actually use from those prereqs? Well, from physics, we'll use this mostly in the second half of the quarter. We'll draw on concepts of force, motion, energy, and power, and some basic electromagnetism to understand how electric motors work, and basic circuits also to understand how electric motors work. From your statics and strength of materials courses, we'll rely very heavily on static equilibrium, especially free body diagrams and free body diagram analysis. It's very, very important in this class. So focus on that in the next few weeks as we brush up. Concepts of stress and simple models of stress, also very, very important in this course. From the ME 102, and this is Foundations in Product Realization, we'll draw on our experience in rapid prototyping methods, including making low fidelity prototypes and 3D printing. And also CAD modeling with either SolidWorks or Fusion 360, and some awareness that we've developed from that course of the kinds of components that are available from catalogs. From ME 103, we'll draw on an understanding of functional prototype manufacturing and the use of visual communication in designs. Now, why are we doing this? We're trying to build up a skill set that's going to be extremely important in a broader design problem that you'll run into in your capstone design courses and out in the real world. So in that bigger design problem, first you need to figure out what someone needs and then generate a bunch of concepts for products that could meet those needs, then make a functional prototype for one of those concepts. And once you've made a few functional prototypes and landed on one that we're happy with, then you design for mass manufacture, and then you market it. So in that bigger problem, this functional prototype stage is very important, especially for mechanical engineers and product designers. And that's what we'll be focusing on in this class, making really good functional prototypes. So the approach that I'm going to teach you in this class is one that's very, very effective for that problem. And in this approach, we'll iteratively apply intuition and ideation, back of the envelope analysis, which is underappreciated and very important to the design of mechanical systems, computer-aided analysis, and the use of functional prototypes in evaluating designs. And there's a topic reading on this approach that's been assigned to you, and that will go into that in some detail. I won't go into detail here. My teaching philosophy for this course is that I want you to become an expert at mechanical systems design. And this is also the subject of a full topic reading that I won't duplicate here, but is due on the same day as this video. So what do I mean by I want you to become an expert? Well, I want you to really gain this skill. I don't want you to jump through hoops or just do busy work. I want you to engage in activities that will make you a better designer when you go out into the real world. That's very important to me. And I think of my role as a facilitator of learning. I can't push knowledge or skill into your brain. That happens by things you do. So I am trying to create an enriching environment with some compelling challenges and feed in the right bits of information and technique ideas so that you will synthesize everything and applying these new ideas to this interesting challenge, and in that process become good at mechanical systems design. Now this can sometimes feel awkward, right? There's a lot of struggle involved in that process. And when we compare it to a course where mostly a professor just tells us what to do and then we do exactly what they said, sometimes it feels like we're not learning as much, but the truth is we're learning more, actually. And this is well studied. So you may not have that feeling of fluency that you get when you watch an expert doing something on their own, but know that you really are gaining the skills. And a related thing that comes up sometimes in this course is you may ask your coach or myself, hey, what should I do for this design? And we'll tell you, okay, here's the process you can go through to answer that question for yourself. And that can be frustrating, but really importantly, the point of this course is not to teach you a good solution to a particular design scenario, but rather an approach to design that you can use in lots of different scenarios throughout your career.
So here are some of the ways that this philosophy is reflected in the course structure. The course has 4 primary elements: topic readings, which is the primary way in which we'll transfer knowledge; videos that mostly comprise exercises, which will give you your first opportunity to struggle with application of this knowledge in the design context; coaching sessions, which will be focused on interaction and give you a chance to ask questions and get feedback; and projects, in which we'll apply everything we're learning to a fairly real-world, open-ended problem.
So the topic readings are the main form of information transfer in the course. And I've noticed that there can be some resistance to sitting down and reading basically a book chapter among students these days. But it is very, very, very important to do that. This is the main way that information, the new information will come to you, and older information will be reviewed in this new context. You really have to read the topic readings. They don't take long, 30 minutes each. And to help motivate you, there'll be a quiz after each one. But think of this as an opportunity to hone that critical technical reading skills. Very, very important as you go into the real world. You will be expected to read things like this in real life. And then we'll have these topic videos that accompany them that solidify and complement, but do not replace the topic readings. So if you're just watching the videos, know that you're going to miss a whole lot of information. Will make it a lot harder to do the projects you'll learn less in the class. The next element are exercise videos. So normally we would do this in class. We'd have in-class exercises where you collaborate with a peer sitting nearby. That's difficult under these circumstances. So instead, we will have videos where we set up the exercises, and then you pause the video at the right time. I'll tell you when to pause and about how long. Work on the exercise and then play it again. And bonus points if you can do this with a friend in the class. I find it really helps to have somebody else to riff off of as you go.
Now, you might be tempted as you're watching these videos to just skip the part where you pause and work through the exercise on your own. Don't do that. It's a bad mistake. This is an essential part of the learning experience in the course. You need to struggle with the application of this new knowledge to a problem where you don't know the answer, because that's what's going to allow you to practice the design thinking that'll serve you well throughout your career, really. If you just watch me work through the exercise, then you might feel like you get it, but you really won't. I'll understand what's happening, but you won't. And that's no good. And perhaps for this reason, we find that there's, in past offerings in the course, quite a good correlation between the proportion of exercises that students self-report independently completing and how challenging they find the projects and how much they feel like they learned from the class. So you might feel like, I don't have time to do the exercises. Actually, you don't have time not to do the exercises, because if you don't do them, the first time you'll really struggle with these techniques is on your project, and it'll take way longer. It won't work out as well, or some combination of those things. And then you'll feel like you learned less in the class. So do those exercises.
We'll also have coaching sessions. These are synchronous, scheduled sessions that I'm working on a schedule right now. You'll get that soon, led by one of our course assistants. And in those sessions, you'll discuss projects. You can ask questions and talk about different aspects of the design process. And if time permitting, do some exercises on the main topics of the day. It's really important that you attend all of these synchronous sessions. We've worked hard to make sure that we can find a time that everybody is able to regularly attend. If a scheduling issue comes up, please let me know right away. And finally, we have our projects. So the projects are, of course, the main element of the course. It's a way to apply your techniques to these realistic design problems. Under these circumstances, we need to do everything at home. So we've put together this 3D printer program. So everyone in the class will have a personal 3D printer, and we put together a pretty nice kit for the class as well. So you'll get a motor and power supply and a bunch of other stuff so that you can have your own little project workshop in your living space and go through. We'll have 5 these short projects. Now, these are hard. It takes a lot of work and time, but the more you put into them, the more you're going to get out of the class. And just keep in mind that these are the main element of a 4-unit course, which is a big, substantial effort at Stanford. For an average student in the course, we expect this will take about 12 hours a week. If you're a little bit rusty on some of these basic topics, you should expect to spend a bit more time to catch up. The last thing to note is I will send you emails. I will be careful to only send you emails with essential information, but I expect you to read and understand the information in every email we send, and you'll be responsible for that information. And I also pledge that we will respond quickly to your emails and questions. You can email us at me104team-team@lists.stanford.edu. And we also have a Piazza site, and we're very quick to respond to posts there as well.
All right, if you haven't done so yet, now is a great time to go read that syllabus in detail. In addition to some of the topics we've been discussing here, it covers our grading policy, the materials that you'll need to complete the projects, and a schedule for the entire quarter, including when topic readings are due, what the coaching sessions will be on, and when projects are due. So worth a very careful read right now. All right, looking forward to a great quarter together.